All right, folks, let's go ahead and get started. I want to apologize for yesterday morning. I thought I had the issue resolved with the internet connection, and it seemed like it went pretty smoothly for the first 3 quarters of the class, and then towards the end, it just kind of fell apart with the with the Zoom meeting. So um, I apologize for that. And so what I would like to do then, and I know it may be a little bit redundant, it may be a little bit, and you would hopefully the material will be familiar to you. But I do want to start with number 8 again, so that at least there's we'll get that continuity, and that way then you can kind of get a better idea about how we're going to go about solving for these problems. And so what I'd like to remind you of then is that as we progress through the video here, I'm going to go ahead and I'm going to make sure then that I'm going to time myself, make sure that the video is going to be right around the 40-minute mark, so that then you'll have time to do your work. And so make sure that at the points where I stop and I ask you to work out some problems, or do a certain part of the problem, please make sure you work it out on on the separate sheet of paper. And then and at the end of the video, submit your work. Submit your work through Google Classroom. I'll post this on Google Classroom, a link to get to this video here. And so you would have followed the link in order to get to this video here. And then so you'll submit your written work by the end of the video. There will be a written portion to this video, so you'll submit your written work onto Google Classroom, and then you'll be done with the video. Okay. So let's go ahead then. Let me share with you my screen. And again, like I said, I know that parts of this is going to be quite redundant, but it's fine. We'll get a chance to review the steps that you'll have to take in order to work through these problems anyway. So I'm going to go ahead and I'm going to work through with you again. Let me see here. Let me get this down. There it is. All right. I want to go ahead and I want to do so number 8 in your problem set. And that's where I'm sorry, number 8 in your textbook. So if you don't have your textbook, please go ahead and grab that textbook of yours, and we'll be working through another problem in your textbook as well. The homework that was due last night. So if you have questions, like I said, I will be available during our class time for you to come by and get your questions answered. And then on Wednesday, so we'll on Wednesday after examine, I'll be available as well for you. So please come by and get your questions answered as well. Okay. All right. So let's go ahead then. Let's take a look at number 8, and let's work through this and the steps you need to do in order to complete a problem like this using the algebraic method to work through this problem. Okay. All right. So the very first thing I pointed out to you then is since these involve forces, draw the free body diagrams. Now, if the vectors are not force vectors, you will not need to draw the free body diagrams, but I think it's always useful to be able to draw the free body diagrams, especially then to get an idea of how these forces are interacting with each other, okay? How these forces are playing out. Okay. All right, so we have this the object here with this the child on the swing. So there's where we have the child or the swing, and so of mass m, we want to make sure we do that as well. And then we have two forces acting on we have two forces acting on this the swing here, this object here. And the two forces then are tension forces, because they are strings, they're roped, pull up on the swing here. So let's go ahead then and let's draw in those forces. We got two force vectors, okay, pointing up and away. So we have one that's kind of pointed into the first quadrant, and the second pointing into the second quadrant. Okay, so we got two vectors of equal magnitude. So we'll have two vectors of equal magnitude, but they're pointing in opposite directions. So we call this one F2, and that one has a magnitude 2.28 newtons. And here, this is F1. We call this F1, and it also has a magnitude of 2.28 newtons. Okay? All right, the difference between these two then are the directions they're pointing in. Okay, that's the key here. But they both make an angle of 13 degrees with the horizontal. Okay, so these both make a 13-degree angle with the horizontal, which means then if you can imagine a horizontal line, an imaginary horizontal line that runs from left to right, and I'm going to draw this using the yellow line. Okay, the angle that each vector makes, so this would be our x-axis. That's our horizontal. So this is our x-axis right here. Okay. So if you can imagine that, each one of these force vectors make a 13-degree angle with that horizontal line. Okay. All right, so with that said then, so now that we have drawn the free body diagram, we kind of have an idea of how these force vectors are interacting with one another. Let's go ahead then, and the second thing you want to do is you want to sketch out the diagram. Okay, so sketch the diagram, sketch the vector addition. Okay. Sketch the vector addition and see how it looks. Okay, see how the resultant vector will look. Okay, so after you've drawn the free body diagram, and again, this diagram here, you only need to draw if we're dealing with force vectors. Okay, so here we have two force vectors. All right, so let's go ahead then and let's draw this. Now, it doesn't matter which one you choose first. Remember, you can choose either one. I'm going to go ahead and I went ahead and I arbitrarily chose F1 here to start out. Okay, so F1 then is going to point up and towards the right, left, okay, and up and towards the left at about 13 degrees. I'm going to try to estimate that. You don't have to measure anything here, folks. It doesn't have to be exact. We just want to have just a general idea of the direction. And again, this angle right here, off of the positive x, off of the x-axis, is going to be 13 degrees. Okay, so this angle right here is 13 degrees. Okay, so we want to draw that in. And this vector here, this is F1. And we draw that in. All right, so to the tip of vector 1, we're going to place the tail of vector 2, which is F2. And F2 then is going to point it up and towards the right, up and towards the right, okay, in that direction. And I'm going to try to make it here as best I can. And this vector here, if you can imagine a second imaginary line running right here, there's a second imaginary line running right there. It's going to make an angle of 13 degrees with this imaginary line right there. So that angle right there is also going to be 13 degrees. And this is our second vector. Okay, so this is the geometric method. When we sketch, when we make our sketch here, this is the geometric method. We're not going to measure anything out. We're not going to measure any lengths. We're not going to measure any angles. We just want to have a rough idea based upon our free body diagram here, a rough idea of the direction our resultant vector will go. And so in order to draw the resultant vector, remember, we're going to start from the tail of the first, and we're going to run all the way to the tip. Sorry, right there. Tail of the first, run all the way to the tip of the second. There is the resultant vector. And that's what we're looking for. We're looking for the magnitude, the length of that vector, and we're looking for the direction that vector is going to be pointing in. That is our answer. That red arrow is our answer. And that's what we want. And what we're going to do here is we're not going to measure anything. Remember, we're not going to measure anything. We're going to use algebra and we're going to use trig in order to get this information about this arrow right here. Okay. All right. So from there, then, to start the algebraic method, okay, is that we're going to take each one of these vectors again, and we're going to draw them, but we're going to draw them independent of one another. So we're going to draw two separate vectors. Okay. So we're going to draw this first vector here, and that's going to be our F1 at 13 degrees. So this is going to be our force vector that we're going to call F1. And again, it has a magnitude of 2.28. So this is going to be our 2.28 Newton vector. Okay. All right. What we can do with this vector now, so I'm going to focus on F1 here. We can draw two more vectors, okay, which are called the components of this vector here. Okay. So we will have then one component that runs right along the x-axis. So this is the blue arrow that I'm drawing here for us. Okay. This is what we refer to then as so this is F1. This is related to the to the original vector here, but it is running along the x-axis. It's running horizontal. It is running horizontal to our original vector here. Okay. And so therefore we call it the x component because it is following along the x-axis. Okay. We can also draw then another vector, okay, that runs straight up. Okay. And if you notice then, these two vectors, when you combine them together, will give you your F1 right here. We refer to this one then as so this is F1, but the Y component of F1, because it runs along the Y axis. So if you notice here, you connect these two arrows here, tip to tail, you will get your this original vector here. Okay? And the reason why we want to do that is then we get this right triangle. If you notice here, we get the right triangle right here. Okay? And based on that, and if we know this angle right here, if we know that angle, we can get information about those two legs. Okay? The lengths of those two legs. Why we need them, I'll get to in just a moment. Okay, but so we need to know this angle, and we do. We're given that angle right here, and that is 13 degrees. Okay, so there it is. There's triangle number one, which relates to F1, which is related to this first vector here. Okay, the second triangle that we're going to draw then is going to be the second vector, okay, which runs up and towards the right. And we can do the same thing. We can draw then two force vectors. Okay, and I'm sorry, this is going to be F2. Okay, this is our second force vector right here, and it has a magnitude also 2.28 newtons. Okay. All right, so we can go ahead then and we can draw two vectors in much the same way we did with the first one. We can draw two vectors that will, once we connect together, give us another right triangle. And there it is. There's another right triangle made up of two vectors. This time, these two vectors here, we refer to then as the X and Y component of the second vector here, of this vector. Okay? So if you notice then, we have drawn two triangles for the two vectors that we are adding together. Okay? So for as many vectors as we have, we're going to draw that many right triangles. Okay, so if we started out with three vectors, and we wanted to add those three vectors together, we will draw three right triangles. Okay, and that's how it's going to work, and that's how easy this becomes. Okay, and so with that said, then we know that this will be the X component of F2. And again, if we know this angle here, we can calculate then for the lengths of these vectors right here. Okay, and we do. This is going to be 13 degrees as well. Okay. All right, so there it is. We start out, in order to do the algebra, to add these two vectors together, we need these two right triangles. Okay, and so like I said, again, for however many vectors you have to add together, you're going to draw that many right triangles. Okay, all right, so with that said, at this point then, we can use the trig. We can use the trig that we know to find then the X components of each of these vectors here. And we can use the trig to also find the Y components of each of these vectors here. Okay. All right. And so you got to make sure you remember the trig functions. So I'll just go ahead and write the trig functions down here again for you in the relationship. So we know then, and I'll write it in terms of our right triangles here. We know then that the sine function relates the angle that we know, okay, so that's what theta is, to the side opposite. In this case then, it's going to be the Y components of F1 and F2 over the hypotenuse itself. Yep. And then we would do the same thing for this triangle. We would know then that the cosine of our known angle, it's going to be the side adjacent here, which is going to be the X component of this triangle over the hypotenuse, which is the original vector. Okay. So knowing these relationships here, we can go ahead then, we can solve then for each one of these here. So let's start then with the X component here. So X component is the side adjacent and the hypotenuse. To find then f of x, we got to multiply both sides by the hypotenuse. Okay? And so therefore then substituting in what we know, hypotenuse here then is going to be f1. The hypotenuse is f1, and we're going to multiply that by cosine of theta. So rearranging this equation here, we get this. Substituting in our numbers, it's going to be then 2.28 newtons times cosine of 13. degrees. Yep. All right. And I'm sorry, let me go ahead and give myself a little bit of room here. Okay, let me give myself a little bit more room here. And so we have here then, if we calculate it and we put it in correctly, we get here then 2.22 newtons. Okay. Now you can do the same thing on this side here. Same thing. This time it's going to be F2 times the cosine of theta. Okay. Substituting this in, it's going to be 2.28 newtons times the cosine of 13 degrees. And we also get here 2.22 newtons. So in both cases then, we get an answer of 2.22 newtons. The difference though is the direction that they're pointing in. Okay, this vector is this x component here is pointing towards the right. This vector here, this x component, is pointing towards the left. And we said then, remember, we're going to follow convention so that if we have an x and a y axis, okay, we will always refer to the right of the x-axis being positive and up on the y-axis being positive. Okay? So therefore, this x component here is going to be positive. It's pointing towards the right. This component here is pointing towards the right. This component here, on the other hand, okay, if you take a look at this x component here, it's pointing, the arrow is pointing towards the left, which means then this has to be negative. So don't forget to include that, okay? All right, so with that said then, we have now the x components. Let's go ahead and solve for the y components of both of these. Okay, so for the y component of the f of 1, it's going to be the force vector times the sine of the angle that we know. That's going to be 2.28 newtons times the sine of 13 degrees. Okay? And if you plug that correctly into your calculator, you get then 0.51 newtons. Okay? And so with that said, we can do the same thing for the y component of F2, which is going to be F2 times the sine of the angle that we know, angle theta. So that's going to be, again, 2.28 newtons times sine of 13 degrees. And we again get 0.51 newtons. And if you look at, if you take a look at the y component of F1 and the y component of F2, they're both pointing up. And we said up was positive, so both of these vectors here end up being positive. And you leave it that way. Okay. All right. At this point then, and this is what we discussed in class, we have now these here. We're not even ready yet to solve for r. Okay. We are now though, because in order to find r here, to find the resultant vector, what we need to make sure we understand then is that in the end, our resultant vector will be represented by an arrow. And the resultant vector is going to be a third, in this case then, a third and final right triangle that we have to, that we're going to solve for. Okay? And so in order to solve for that then, this resultant vector actually ends up being the hypotenuse of our right triangle, which means then we need then the x component of that resultant vector, okay, and the y component of that resultant vector. And how we obtain these x and y components here is by adding these x and y components together up here, which means that we're going to take then the x component of vector 1, and we're going to add it to the x component of force vector 2. Okay? And so with that said, then we add it together. It's going to be then a negative 2.22 newtons. Okay? And we're going to add that to a positive 2.22 newtons, which gives us 0 newtons. Okay? All right, so that's going to be the x component, which means then the way that you want to think about it then is that if you think of the right triangle, the x component here is the side adjacent. Okay, and if you notice here, or what follows on the x-axis, there's nothing. There's no part of this vector here that points along the x-axis, which leads us to conclude that this vector here, the resultant vector, is either going to be pointing straight up or straight down. Okay, and that's what you want to make sure you keep in mind. Okay, all right. So with that said, then let's calculate for the y component of this resultant vector. And I hope the color coding helps a little bit and doesn't throw you off. Okay, but we're solving now for the resultant vector. Okay, All right, and this is the first step. The first step here, and this is where we need to start solving for the resultant vector. We have to then find the components. Okay. All right, so then that means then we will take then the y component of force vector 1 and add it to the y component of force vector 2, which is going to be then 0.51 newtons positive plus a positive 0.51 newtons, which gives us then 1.02 newtons. And it's in the upward direction, and it's positive there. Okay. All right. So there it is. So this right triangle actually is not a right triangle. The resultant vector then is going to be pointing straight. But in order to get that, okay, we got to go to, let's go ahead and continue on. I think you should probably start seeing this already. Okay. So the resultant vector, to get the length of the resultant vector, we're going to use the Pythagorean theorem, which is going to be then the square root of r sub x squared plus r sub y squared. Okay. So we got to take these two legs here. So these two legs, and to get the hypotenuse, we're going to use the Pythagorean theorem. So substituting in our values here, r sub x is 0 newtons. We're going to square that. Plus the r sub y is going to be 1.02 newtons. And we're going to square that. Okay. And take the square root. So therefore, there it is. The resultant vector, and this is the first half of our answer right here, okay, has a length of 1.02 newtons, has a magnitude of 1.02 newtons. Okay. All right. And then finally, we got to get the direction here. We got to get the direction of the of this vector here. And so we used an inverse tangent. I'm sorry, the direction would be the angle. So let's go ahead and do that. Okay. So the angle theta, then it's going to be the inverse tangent of opposite over hypotenuse. It's going to be ry over r sub x. Okay. All right, so plugging that in, then it's going to be inverse tangent of 1.02 newtons over 0 newtons. It's going to be an undefined value, but we know then the two angles that give us the undefined angle is going to undefined value is going to be 90 degrees and 270. Okay, so this is going to be upward, and this is the reason why we wanted to draw this sketch here. This is going to be 90 degrees with straight up. Okay. And that is going to be our answer. And again, based off the positive x-axis. Okay. All right. So if you have any questions about this, I'm going to go ahead and save this, and I'll post this for us tomorrow. Okay, so I'll post this, but let's go ahead. Let's practice this a little bit more. Let's practice this a little bit more. Let's go ahead and turn in your book. So I'm going to go ahead and I've saved this. I'm going to clear the drawing here. Okay, I would like you to work out then. I'm sorry. Let me ask you to. I'll break it up in parts. On your paper right now, let's turn to page 80 to page 142. So in your book, turn to page 142, and I want you to draw. On page 8, so number 85. Okay, and this is going to be on page 142. Okay, so they give you the free body diagram. So number 85, they give you the free body diagram already. Okay, what I would like you to do on your paper right now, what I'd like you to do is I want you to sketch the vector addition. Okay, so take about 30 seconds. Take about 30 seconds. I hope it shouldn't take you any longer than that. Take 30 seconds on your paper. Sketch the how you would add those two vectors together. So you're given two force vectors in number 85. You're given two force vectors, a 500 Newton vector and a 400 Newton vector. You see the angles there. I want you to sketch the vector addition on your paper. You won't have to include anything on Edpuzzle itself. Okay. So if you want to type something in the box, just type in answer on my paper. Okay, so that's all you have to do for Edpuzzle. But on your paper, I'd like you to sketch this problem right here. So don't measure anything out. You won't need any rulers. You won't need a protractor. But I want you to freehand what this will look like. So take about 30 seconds, draw what you think, and then when you unpause it, okay, let's compare your answer to what I draw up here. Okay, so take 30 seconds and draw this sketch this vector addition. Okay, hopefully you had it sketched out. Okay, let's go ahead then, and what I'm going to do then is, remember, it doesn't matter which one you choose first. It doesn't matter which one you choose to sketch first. I'm going to choose then the 500 Newton vector. Okay, so we have the 500 Newton vector. It looks like it's moving up and towards the left. Okay, so I'm going to draw that out. It's 500 Newtons. I'm going to try to draw the arrow right here. So there's about 500 Newtons, and it's sitting at about 40 degrees with the horizontal. Okay, so let's go ahead and put that in, and I'm going to quickly draw the horizontal here to kind of give us a reference point. Okay, so there's the x-axis. There's a horizontal, and so this angle right here is going to be 40 degrees. So this angle right here is 40 degrees. Okay, and our force vector here, we'll call this F1, is 500 newtons. And there it is. Now, to the tip of this vector here, we're going to place the tail of the second vector. And again, just quickly drawing this horizontal line right here. The second vector then is going to make an angle of 50 degrees. The second vector is going to make an angle of about 50 degrees. Exaggerate. It's 50 degrees, and it's about a 400 Newton force, 400 Newton force. I'll make it a little bit shorter. And so this is going to be F2 right here. So if you draw this right here, this angle right here, made off of the, again, positive x-axis, is going to be 50 degrees. Okay, and this vector here, F2, that's our F2 vector, and that is 400 newtons. And so that's what you want to draw, and then hopefully you were able to draw the resultant vector. The resultant vector, starting from the tail of the first, it's going all the way to the tip of the second. So now we have a general idea of the direction our resultant vector is going to move in. We don't know the length, okay, but we do know, and we're going to calculate for it, but we do know then the direction. It looks like it's going to be heading in towards the second quadrant. Okay? So that's why we want to draw the rough sketch. So compare what we have here, what I've drawn for you here, with what you have on your paper, and make sure you come by and ask on Wednesday if you didn't quite get that. Make sure you come by and ask. Okay, but let's move on. Let's move on then. Okay, what I'm going to do next for you then is let's go ahead then, and we want to separate. So let's go ahead. Our first step then is we're going to separate out these vectors, and we're going to draw the two right triangles that they make. Okay, so let's go ahead and do that. Okay, so I'm going to go ahead and draw this 500 Newton vector first. Okay, so let's go ahead and draw that 500 Newton vector. There it is. There's the 500 Newton vector. Okay. And so this is force vector 1, and that's going to be our 500 newtons. Okay, and so with that said, then let's go ahead and let's draw the x and y components. Okay, so here we have the x component for force vector 1, and then we will go ahead and also draw the x component, and the y component. So there it is. There is the right triangle number 1. There's our first right triangle. Okay, and here it is. There's our first right triangle, and made up of these two vectors here. This is going to be then, this one that's going to be then the y component of vector 1. Okay? And this here then is going to be the x component of vector 1. Okay? And so we need to get those, the lengths of those, and we know this angle right here, okay, is going to be 40 degrees. 40 degrees. So there it is. There's right triangle number 1. Remember, for every vector that we that we're asked to add together, we're going to have that many, that same number of right triangles. Okay, so let's go ahead and draw the second right triangle then, because there's the second vector here. So the second vector here then is going to be a 400 Newton vector. And if you notice here, I'm not even concerned about getting the length of these arrows correct. We just need to make sure we point them in roughly the same direction. Okay? So therefore, this second vector pointing up and towards the right, and this is a 400 Newton vector. Okay, and so let's go ahead then and draw on the legs of this right triangle. Okay, we have then the x component here moving towards the right. Okay, and then we're going to have then the y component up, pointing straight up. Okay, so there is our second right triangle right there. And so this is going to be then the y component of the second vector, vector number 2. Okay? And this one's going to be then, okay, for vector number 2, force vector 2, the x component. Okay. And we know this angle right here. We know that angle for this right triangle. That angle then is 50 degrees. Okay. All right. What I would like you to do on your paper, so take about 2 minutes now, take about 2 minutes. What I'd like you to do on your paper then is I would like you to show me how would you solve then for the x components of both of these vectors. Just show me how you would solve then for the x components of each of these vectors. And I want you to show me then how you would solve then for the y components of each of these vectors as well. So take about 2 minutes on your paper, solve for the x components and the y components of each of these vectors. Okay, 2 minutes. Okay, okay. Hopefully, hopefully you got it. If not, let's compare your work. Let's compare what we have here. Okay, so the x component here is the side adjacent to this angle. We know this angle, and the x component is side adjacent, and we know the hypotenuse for this triangle. So with that said, then we're going to use the cosine. Okay, so it's going to be then f1, the hypotenuse, times the cosine of the angle that we know. That's what theta represents. Okay, so it's going to be then 500 newtons times the cosine of 40 degrees. Okay, and so plugging that in, let me go and do that. Cosine of 40. Let me. Oh boy, I hope. Sorry, guys. Let me. Oh, let me get my calculator really quickly. I think got a little bit off here. So let me just check my work really quickly. So we have then 500 times the cosine of 40. Okay, I get 383. So it's going to be 383 newtons for this vector here. Let's do the same thing for this x component here. That's going to be then f2 times the cosine of this angle. So let's go and plug that in. That's going to be then 400 newtons. Okay, times the cosine of 50. And I think I have that one. 500, 400 times the cosine of 50. That's 306. Okay. 306 newtons. All right, so that's how we got the x and y components of those two. Let's go ahead then and let's switch over to the y components here. So the y component then is the side opposite and we the angle that we know. So we're going to use the sine function. So therefore this can be f1 times the sine of the angle that we know, which is sine theta. That's going to be then 500 newtons. Okay. Times the sine of 40 degrees. Okay. All right, so 500 newtons times the sine, I'm sorry, so like same thing, 500 times the sine of 40. Okay. I get that 321 newtons. Okay. All right, let's do the same thing for the y component here, which is going to be f2 times the sine of theta, which is what we know. It's going to be then 400 newtons times the sine of 50. Okay, and so let me go ahead and get that for you. That's sine 50 for that's gonna be 30. I'm sorry, sine 50 306. Sorry, let me just check my. I think I was. So this is sine 50 400. That's 306. Yeah, sorry. I think I made a mistake up here. So 400 cosine 50. This is 257, you guys. Sorry about that. Yeah, something looks strange up here. So this is 257. Sorry. This can be 257 newtons. That's going to be cosine 50 for 257. Okay, so let me just check my math again really quickly. So cosine 50, 400, 257, sine 50, 400, 306. Okay, so there it is. Those are the x and y components of these two legs here. All right, so now we have the length of these two legs again. What we're trying to get after then is the r here. So we're going to go ahead and we're going to add together. We're going to sum up all of the x's and all of the y's. And if we do that, then we will get the x component of our resultant vector and the y component of our resultant vector. Okay, so let's go ahead and plug that in really quickly. This is going to be then f1, the x component of f1 plus the x component of f2, which is going to be then, and again, the last thing we have to do before we add them together, we got to make sure that we indicate direction. Okay, so if you take a look at this then, okay, this is going to be 383, but towards the left, so that's going to be negative. Okay, this is 257 towards the right, so that's going to be positive. Okay, this is 321 up, which is going to be positive, and this is 306 up, and that's also positive. Why is that important? When we go to add these vectors together, we also have to indicate direction. So this is going to be negative 383 newtons, okay, plus a positive 257 newtons, okay, and let me see here, 383, and this can be negative 126 newtons, okay, and that's what we have for the x component, okay, and let's go ahead and do the same thing for the y component of the resultant vector. We add then f1, the y component of f1. We're going to add that to the y component of f2, which is going to be 321 newtons plus 306 newtons. And I get here 306, 321, 627 newtons. Okay, so those are the x and the y components of the resultant vector here. So with that said, that in order then to, and that's going to be the first step towards our solution, okay, and so in order to get the resultant vector, the actual length of the resultant vector, we have to use the Pythagorean theorem, and we're going to take then our the x component and square that, and add that to the y component, square that, the square of the y component, and take the square root of the whole thing. Okay, so therefore, r then is going to be the x component here, going to be minus 126 newtons, and we're going to square that, plus 627 newtons, and we're going to square that. And then I get, for this one, 126, 627, I get an answer then as 640, two significant, 6.40 times 10 to the second newtons. Okay, so I get 640 newtons as the resultant. Okay, so there it is. That is the length of this resultant vector here. Now we got to finally get the angle here. Okay, and let's get the angle, which is going to be then the inverse tangent of the y component over the x component. So let's go ahead and substitute that in. This one, that's going to be 627 newtons over a negative 126 newtons. Okay. And then we get an angle then that is negative 78.6 degrees. Now, with that said, then what we need to do here is, because there's multiple, there could be other negative 78.6 degrees. We say then, and this is the reason why the sketch is going to be important. This is going to be then 78.6 degrees above the negative x axis. Okay, and so that will be the final answer. Okay. So the two answers here then is going to be then this length. Oops, sorry. This length right here and that direction right there. Okay. All right. So what we'll do on Thursday then is I want to work through one more problem with you involving these components. Take your questions, but feel free to ask questions on Wednesday after the examen. But I'll take your questions on Thursday. Please make sure then that you at the end of this video you post your work here on Google Classroom. Okay. All right. Have a good rest of your day, you guys, and I will see you tomorrow during the examen. Okay. And hopefully I'll see a few of you for the office hours as well. Okay. All right. Very good. I'll see you folks. Let me save this here. I'll see you folks on Wednesday.